It was a holy moment. The Andromeda Nebula overnight became the Andromeda Galaxy.
The James Webb Telescope has identified 6 galaxies that exist 500 million years after the Big Bang. This is incredible. When you look at the night sky, you have a pinpoint of light. A pinpoint of light in the night sky expanded gives you one of these pictures from the Webb Space Telescope.
When the Andromeda Nebula changes into the Andromeda Galaxy, the time of holiness arrives. Our understanding of the Andromeda Galaxy was confined to ground-based observations for a considerable amount of time. But because to technological advancements and the development of the James Webb Space Telescope, our comprehension has expanded beyond spatial limitations. That is about to change, though, as a warning signal from the Andromeda Galaxy has been detected by the James Webb Space Telescope. These signals have an impact on the scientific community, inspiring and piquing scientists' curiosity. Therefore, what do these indications mean? Above all, why do astronomers find them concerning? Join us when the James Webb Telescope shuts down after just 2 minutes after receiving a warning signal from the Andromeda Galaxy. The technology utilized to examine several galaxies and individual stars is the major cause of this argument, since previously we were able to see the far globe. However, the discovery of the Andromeda Galaxy altered everything. This is the first indication that there is more to the cosmos than just the Milky Way. The origins of human imagination date back to the 17th century, when Galileo Galilei's groundbreaking use of a telescope to confirm the Milky Way's actual existence was revealed. He discovered that the Milky Way's star population is so great that it casts doubt on the idea of its central region. When Edwin Hubble used the Hooker telescope to view far-off Milky Way objects in the 1920s, everything changed. Edwin found out that these moving objects on Earth were galaxies other than the Milky Way. The Andromeda Galaxy, often known as M31, is one of these galaxies. The Andromeda Galaxy was originally observed by Iranian astronomer Avd al-Rahman al-Sufi in the 10th century, despite the fact that humans have just recently been able to view it with a telescope. Astronomers were able to observe and comprehend the existence and significance of Andromeda in the 20th century because of technological advancements. The Milky Way is modeled after the huge star nebula known as Andromeda. Its distance from the Milky Way, our cosmic neighbor, is around 2.5 million light-years. Our understanding of the Andromeda Galaxy has changed since its discovery. We transitioned from using telescopes for terrestrial observations to using space observatories like the Hubble and James Webb Space Telescopes. Every technological breakthrough raises us to new levels and contributes to our understanding of the mysteries of the Andromeda Galaxy. Andromeda is a model for researching galaxy formation and development, since we now have a better grasp of its structure. This helps us comprehend the functioning of the cosmos better. Scientists think that studying the Milky Way's link to the Andromeda Galaxy will help us comprehend our planet better. This is especially true given that after around 4 billion years, a collision between two galaxies will unavoidably occur. Signals regarding the Andromeda Galaxy were recently received by the James Webb Telescope while investigations and studies were underway. Scientists from all across the world were frightened by the warning signal and wondered about its origin and its consequences. The Andromeda Galaxy Center has shown anomalous activity, as revealed by the sophisticated sensors of the James Webb Telescope. The signal returned to the researchers indicated that experts from all around the world were interested in the difference from earlier measurements. This signal points to significant Milky Way processes that may be connected to this supermassive black hole or to as yet unobserved phenomena. More significantly, a recent discovery raises the possibility that the Andromeda Galaxy is bigger than the Milky Way, which would alter our perception of the two galaxies' relative sizes. Additionally, the James Webb Telescope produced comprehensive pictures of the Andromeda Galaxy that shed light on the chemistry and creation of young stars. Understanding the Milky Way's development and living circumstances depends on this new knowledge. Furthermore, Data from telescopes reveal higher energy in the Andromeda galaxy's active nucleus. In the end, this impacts the ecosystem and is anticipated to enhance its structure going forward. In addition, scientists can learn more about the distribution of dark matter in the Andromeda galaxy by studying how gravity affects its stars. I hope this clarifies its effect on the ever-changing globe. In actuality, one of astronomy's biggest problems is comprehending dark matter and how it affects the cosmos. A new finding by the James Webb Telescope has sparked several investigations worldwide as researchers try to unlock the mysteries of the Andromeda galaxy. We get deeper insight into the past and future of the galaxy as new knowledge becomes available. So what scientific knowledge about the Andromeda galaxy do we have? The Andromeda galaxy stands out from other galaxies in the cosmos thanks to its remarkable characteristics. Its enormity has drawn attention. Current estimates place its diameter at about 220,000 light-years. With this magnitude, it surpasses even the Milky Way in size as one of the biggest galaxies in the local group of galaxies. Its mass is determined by its size, which is thought to hold billions of stars. The structure of the galaxy has piqued the curiosity of scientists. The Andromeda galaxy features a bulging, thick atmosphere in contrast to spiral galaxies. This is a really fruitful place to bring the stars together. Among its many interesting aspects is its importance. It is distinguished by two emission peaks that point to a supermassive black hole that is distinct from the Milky Way, but comparable in nature. This offers crucial details on the composition and functions of these massive, dull items. Hundreds of thousands of light-years across, a ring of stars, planets, and globular clusters still encircles the Andromeda galaxy. This ring is made up of stellar debris. This cosmic stratum displays comprehensive details on the Milky Way's genesis and past. The Andromeda galaxy's 460 globular clusters shed light on early star formation as well. This demonstrates unequivocally how star clusters arise and how galaxies first emerge. Astronomers are getting a better grasp of the consequences of darkness on the cosmos by solving the puzzle of the Andromeda galaxy. However, a question still has to be answered. How do they explain its mystery and how it affects galaxy dynamics? Satellite galaxies are an additional characteristic of the Andromeda galaxy. There are about 20 dwarf galaxies in the halo structure, some of which have lost most of their gas and stars. In this process, neighboring smaller galaxies are drawn to and destroyed by the bigger galaxy. This shows how galaxies expand and interact with one another throughout time and depicts the dynamics of cosmic evolution. What then lies ahead for the Andromeda galaxy? Not only do astronomers find the form and direction of its motion fascinating, but so do anyone who are interested in understanding the world. An essential aspect of the Andromeda galaxy's formation is the potential for spiral galaxies to become ring galaxies. There is evidence that this process will result in more unusual connections, maybe from interactions with neighboring galaxies or from galaxies colliding. Andromeda has interacted with other galaxies extensively since its formation, if it is indeed moving in this direction. Ultimately, Andromeda's destiny rests on its approaching clash with the Milky Way. This model predicts that the collision will happen in about 4 billion years. These two massive objects collide and create a new galaxy as a result. Collisions, while destructive, are a necessary aspect of galactic growth. However, there is no clear relationship between this galactic collision and the vast distance between galaxies. The two galaxies will reassemble and assume new forms and components following the collision. Giant mirrors in the sky and the creation of new stars are the results of gas and dust interacting. An elliptical galaxy would eventually arise as a cluster of brilliant objects as a result of such a cosmic catastrophe. There is a lengthy history of mishaps worldwide. Therefore, these kinds of incidents are not unusual. But we are concerned about our direct involvement. This celestial show is further shrouded in mystery by the anticipated merger of supermassive black holes at the centers of two galaxies. This demonstrates the intricacy and profundity of cosmic development. Massive radiation would be released as a result of the merging, exploding the material the black hole had been swallowing. Their method yields valuable insights into the lifetime motion of galaxies and the impact of black holes on their evolution. However, it begs the crucial issue of what will happen to our solar system following this merging. The Sun won't entirely vanish. Rather, its circumstances and attitude will shift significantly. This implies that recently created galaxies have the ability to change and possibly explode. Scientists can study the scope of related events and the eventual fate of our galaxy to gain an understanding of this process. It is crucial to remember that because galaxies are so far apart, star collisions are uncommon in space. However, variations in gravity have the power to disturb stars' fixed locations and alter their orbits, even that of the Sun. The global climate may be significantly impacted by these changes. Relocating away from or towards the Sun is one of the most significant transformations that humans may go through. Heat or cold may result from this. Sea levels may increase as a result of glaciers melting and fresh ice forming in warmer areas. To make matters worse, the shape of these devices may also interfere with the amount of radiation that reaches Earth. In fact, the link between heavenly bodies is indicated by the conjunction of the Milky Way and Andromeda. The gravitational pull of the two galaxies' black holes will intensify the global flow of high energy as they get closer in time. This will ultimately result in more cosmic radiation penetrating our atmosphere. The potential for radiation levels to rise might be dangerous for the ecosystems of our planet, since it could alter biodiversity and lead to population shifts. The distribution of habitats is predicted to be impacted by the reversal of Earth's orbit or axis following the black hole merger. One of the consequences of global climate change is how organisms adapt to potentially harsh environments through changes in biodiversity and ecosystem structure. While several species will flourish in their new habitat, others will go extinct or become very endangered. As the atmosphere in the nebula accumulates and compresses, this merging might result in the birth of new stars. Radiation from these nascent stars has the potential to modify the environment, changing the atmosphere and the ecology as a whole if this process takes place close to the Sun. Even if these incidents shape the overall story of Earth's history, it's crucial to recognize the historical background and contextualize the happenings. The accident-caused events occur thousands of years in the future, and it's possible that people have evolved significantly by then. We could already be outside the Milky Way or someplace else inside it. The knowledge gathered by studying the Andromeda galaxy seems to hold the key to comprehending our galaxy's evolution going forward. By comprehending the distinctions between Andromeda and our own galaxy, more precise models of galactic dynamics and evolution may be created. Determining the Andromeda galaxy's size and form is a task as it has an immediate impact on our comprehension of the Milky Way's composition. It challenges our preconceived notions about the Andromeda galaxy and the necessity to reconsider its significance among our galaxy's neighbors as a result. According to recent evidence, the Milky Way and Andromeda are both far bigger than our own galaxy and have similar sizes. This has implications for our knowledge of the Milky Way's place in the local group of galaxies, as well as the strength of the gravitational pull these galaxies exert on us. Despite the Milky Way's current appearance as a restricted spiral galaxy, future interactions with the Andromeda galaxy are likely to have altered its structure. Thus, tracking the Andromeda galaxy's history might provide light on the mechanisms underlying significant changes in the galaxy. Examining the Andromeda galaxy's current status and forecasting the route of the next Milky Way collision reveal a great deal. The distribution of gas and dust, as well as variations in star formation, will be modeled by cosmologists. Technological developments that altered space science also contributed to the genesis of this structure, in addition to modifications in the cores of the two galaxies. Because of this, every journey is better than the last. With the development of the telescope in the 17th century, astronomers were able to see Venus' phases and the Moon's motions around Jupiter. Telescopes become more complicated over time. Large, powerful telescopes were developed in the late 19th and early 20th centuries. With the discovery of new objects like Neptune, astronomers gained greater access to the world beyond Earth. Despite facing challenges like fog and light pollution, ground cameras were still able to offer an amazing view of the enigmatic planet. When the Hubble Space Telescope was launched in 1990, space science advanced significantly. In addition to enabling us to observe the cosmos from a great distance above Earth's atmosphere, Hubble eliminated doubt from our understanding of the universe. The depth and analysis are now more evident than previously. Black holes, the antiquity of the cosmos, and the ongoing expansion of space are all becoming better understood thanks to Hubble. It enhances our comprehension of the cosmos in concert with the Hubble Space Telescope, the Chandra X-ray Observatory, the Spitzer Space Telescope, and other space observatories. They solve Earth's issues and take a spacecraft view of the planet. Radio, infrared, and X-ray observatories, in addition to telescopes, have significantly increased astronomers' possibilities for viewing the sky. Astronomers use these tools to analyze and identify a wide range of events. This comprises the leftovers of supernova explosions, star-forming regions, and the Earth's microwave background. Still, one of the most significant and fascinating phenomena that scientists are working to comprehend is darkness. It is 90% of the cluster of galaxies, but has not been found yet. The inability of dark matter to be found using traditional detection techniques is one of its distinctive characteristics. In contrast to other observable celestial objects, dark matter can only be identified by radiation, large-scale Earth models, and its gravitational impact on visible objects. Changes in the galaxy are what give rise to the dark matter seen in the Andromeda probe. Stars near the periphery have rotation speeds that are similar to those of stars in the center, defying the expectations of early theories. This indicates that a large amount of dark matter-generated invisible matter is circling and affecting galaxies. It is evident that there is more dark matter in the halo than invisible stars in addition to the observation of the Andromeda galaxy. The velocity of the moons, galaxies, and star clusters around Andromeda is significantly influenced by the gravitational field of Andromeda. Astronomers can ascertain the distribution of dark matter in galaxies by examining orbital motion. These observations reveal that the dark matter ring surrounding Andromeda is spherical in shape and size, extending outward 1 million light-years from the star's center. Furthermore, the Andromeda galaxy's dark matter structure is erratic. The galaxy's center is where mass is concentrated, and it spreads outward from there. The development and evolution of stars and atmospheres in the galaxy are altered by this dispersion. By adding extra spiral arms, it modifies the freshly generated star's value and location. Beyond this, the ultimate form of cosmic events, galaxy mergers and collisions, are believed to be largely influenced by dark matter. Therefore, one of the main goals of contemporary astrophysics is to unlock the mysteries of darkness. It ought to open doors to a more profound comprehension of the origins and development of the universe. Not only are the two galaxies merging, but their huge dark matter is also going to collide with the Milky Way in the near future. The two galaxies' unseen surrounds, which are crucial to the appearance of the combined galaxies, will be ejected during the collision. Scientists' knowledge of the origin and evolution of galaxies in the early cosmos has been bolstered by observations of the Andromeda galaxy. Astronomers have shed light on the significance of the minute processes that shape and transform galaxies over tens of millions of years by closely examining the structure of these massive objects. This process, which often takes place after pairs of galaxies drift and merge, involves the emergence of arms and the creation of cores. This knowledge aids cosmologists in customizing galaxy models to match the cosmos. Additionally, the Andromeda signal contributes to increasing the precision of cosmic latitudes and distances. By comparing the relative sizes of nearby stars to the larger cosmos, methods for determining the universe's size can be made even more accurate. This measurement is significant because it establishes key cosmological parameters that are used to interpret the universe's expansion, such as the Hubble constant. Furthermore, studying the chemical makeup of the stars that comprise the Andromeda galaxy can reveal details on the processes of star formation and death, as well as the chemistry of the planet. Our comprehension of nucleosynthesis and related chemical processes in the early cosmos has been greatly enhanced by these findings. Thank you for watching another episode. While you're here, be sure to click the video icon on your screen to see more heartwarming videos like this.